All right, it's great to be here and see so many people who care about private wells. So that's a great thing. Thanks for being here. I'm going to talk about arsenic and radioactive water treatment, and this is my disclosure. Basically, mention of trade names or products is not an endorsement. So first off, arsenic and radioactive elements in water are colorless, odorless, and tasteless. The only way to know they're in the water is to test. And so we do a lot of testing in New Jersey. My colleague Nick talked about it yesterday. And what we find is the naturally occurring elements measured by gross alpha for radioactive elements and arsenic are the two most common contaminants to exceed our testing. And we've tested over 86,000 wells, and 10% are failing for gross alpha and 9% failing for arsenic. The man-made contaminants are like a third of that, which was a surprise because of in New Jersey with our industrial history. We're drilling a hole into the ground and pumping the water out and drinking it, and the geology is a major factor. So probably many of you have seen this USGS map from 1999 showing where the arsenic hits are. The red triangles are bad for arsenic. Notice there's a lot of areas that there's no data, and it's really important to remember that no data does not mean the water is clean. If we move up to 2017, we see inside those red circles, we now know that the population is at risk there for arsenic contamination. So we need to do more testing. So let's get into water treatment. What's needed? It needs to be, the system for a homeowner, it needs to be user-friendly, it needs to be low maintenance, it's got to be efficient, and it's got to be safe for the health of the family and for the environment. I'm going to start with what does not work for arsenic removal. So water softeners do not take out arsenic. Activated carbon doesn't take out arsenic. Brita filters don't take it out. They're just carbon filters. And magnets attached to the pipes don't take out arsenic. So we had a guy come to us and said, I'm the PowerMax magnet company. If you attach these magnets to the pipe, they'll reduce arsenic. And now I know I should have sent him to WQA, but being adventurous, I said, hey, we have some wells, we'll try it. And here you see the results. The raw water came in at 35 micrograms per liter arsenic, and it came out at 35. He said, well, you didn't wait long enough. And so we tried it for several months, and we got the same results. So what does work? There are some issues that we need to deal with arsenic treatment. So the three main factors are what arsenic species is it? There's two main inorganic arsenic species found in well water, arsenic-3 called arsenite and arsenic-5 called arsenate. Arsenic-3 is a problem because it's uncharged and difficult to treat. Arsenic-5 is an anion, negative charge, and it's basically very easy to treat. pH is an issue. Arsenic's very sensitive to the treatment is very sensitive to pH. And there's co-contaminants that can cause problems. So the formula for success that I have found through my experience is that first we need to convert, if there's arsenic-3, we need to convert it to arsenic-5, adjust the pH, and deal with the co-contaminants, and you'll be all set. But you may ask, well, what species do we have? So we need to determine what arsenic species there is. So there are some commercial labs that will do it, but it's very limited. And there's a problem. You just can't fill a bottle with water and send it off to the lab because arsenic-3 may convert to 5 on the way to the lab. So to get over that issue, we came up with a rule of thumb in New Jersey. Looking at the dissolved iron, if it's above 100 micrograms per liter, the manganese is above 50, or you have sulfur odor, you probably have a high percentage of arsenic-3. If you have all three of those, it's like definite this is arsenic 3. If you have 2 of them, it's still very confident. Another way, though, is to use these arsenic speciation cartridges, which are available commercially. The cartridge only removes arsenic 5. So what you do is you're going to collect 2 samples just to send for arsenic analysis at your regular lab that you would use for arsenic. So fill the first bottle with raw water, and then you're going to draw some raw water up into a syringe and pass it through the arsenic speciation cartridge and squirt that water into another bottle labeled arsenic 3. So the cartridge is going to take out all the arsenic 5, and that second bottle will just have arsenic 3 in it. You send both samples to the lab, and now you have total arsenic from the raw water, arsenic 3 from the speciation cartridge, and then you can subtract and get your arsenic 5, and you'll know exactly what you're dealing with. So if you have arsenic 3, what are you going to do? You need to convert it to arsenic 5. Chlorine, I have the most experience with chlorine. It's very effective. However, there's some cons with chlorine. So the homeowner needs to maintain and mix the chlorine. And homeowners are not good at this. Like, how much chlorine do I put in? How much water? Oh, I forgot to do it for 6 months. The pumps, in my experience, the pumps often lose their prime, and if it's not pumping the chlorine into the water, you're not getting the conversion. You're going to make some, maybe if there's carbon, you're going to make some disinfection byproducts, and then you're going to need a carbon tank to remove the chlorine and the disinfection byproducts. So there's pros and cons. Other oxidizers are hydrogen peroxide and ozone. I hear favorable reports. I don't have any. I have limited experience with those in New Jersey. Another way is you can just use straight aeration, which is pumping compressed air through the water column. We found this to only be partially effective, maybe getting an 80% conversion of the arsenic 3 to arsenic 5. The air pumps are very noisy. The air may be contaminated. Picture the homeowner does some painting and leaves the paintbrushes to dry down in the basement next to the tank. Tank does a cycle, and now the water smells and tastes like paint. So there's issues there. One of my favorites is aeration with a manganese dioxide catalyst, commonly called an iron breaker. These are effective and low maintenance, so there's no mixing of chemicals, no injection, and it works pretty effectively. The only issue with these is that they can accumulate radium, so you only want to use a manganese dioxide catalyst type media if there's no radium in the water, and I'll get into that more in the radiation part. One at the very bottom of this slide, I talk about a benefit of any of these oxidation methods is if you have dissolved iron in the water, the oxidation is going to convert the dissolved iron into ferric iron, and that ferric iron is going to adsorb arsenic. And the removal, and then that iron is going to get backwashed out of the system. So we see very commonly, if you have enough iron, you can remove half the arsenic right in that step. Here's a schematic, real-life data of a well. This well has arsenic 3, 80 micrograms per liter. All the arsenic, it's 100% arsenic 3. It has iron at 1.2 milligrams per liter and manganese at 216. So I'm going to show some numbers. The red numbers, the first number is the arsenic 3, the second number is the total. So down in the left-hand corner, the arsenic's coming in at 80 micrograms per liter. The chlorine's injected. You need a chlorine water contact tank and then backwashing media to remove the iron that got precipitated. And then at the sample tap after that step, we see that we're non-detect for arsenic 3, and we only have 40 micrograms of arsenic left in the sample. The water then goes through what we recommend is 2 arsenic adsorption tanks, where the first tank, we call it the worker tank, or you can call them lead lag. I like to call them the worker tank and the safety tank, because eventually, well, you're going to start at non-detect after the first tank, but after time, it's going to start to get filled up, and you're going to get 1, 2, 3, 4, 5, and so on arsenic coming through. So at this sampling event, those tanks are about 2 years old, and the arsenic 3, this is after the worker tank, is non-detect, and the total arsenic coming out of the worker tank is 3.5 micrograms per liter. So the second tank, the safety tank, is going to do a little work to pick up that extra arsenic. Eventually, when you get like 10 micrograms per liter coming out of the first tank, the homeowners had no arsenic exposure, and that's a really good thing. Let's say they were drinking the water for 20 years, so they've been exposed to arsenic for a long time. Now they got the treatment system, so 0 exposure would be really nice. But when you have 10 coming out of the first tank, you pull that tank out, move the safety tank into the worker tank position, and then put a brand new tank as the safety. Then in this case, we've got the carbon tank, and the homeowner insisted on a water softener at the end, and we have non-detect for 3 and total arsenic going up into the house. That's a schematic. This is what it looks like in real life, and you have a water treatment system in your basement. Sometimes, I mean, this is bad water, right? It's got arsenic, arsenic 3, iron bacteria, it's got sulfur odor, and so sometimes you need a significant system. That's what it looks like. So what about pH? That was arsenic, dealing with the arsenic 3. So arsenic absorption works really well below a pH of 8. Above pH of 8, it's a problem. And in our area, a lot of the arsenic wells are above 8. So what we recommend, what I like to see is an anion exchange unit. We have the water is high in bicarbonate, and the anion exchange unit will drop the pH about 2 units in this water. So if you're starting at 9, the pH is knocked down to 7, and you're going to get good absorption. And you also have the benefit of the anion exchange. If it's arsenic 5, it's going to remove the arsenic anyway. But I like to always see backup behind an anion exchange unit because there's issues with anion exchange, which we'll get to in a sec. So for arsenic 5 treatment technologies, reverse osmosis will work, but it only works effectively on arsenic 5. Point of use is the only level that works good with RO. We never recommend whole house RO. Anion exchange removes only arsenic 5 as well because it's an anion. Remember, arsenic 3 has no charge. So there's issues with anion exchange that you may, if the system is not maintained, you may dump the arsenic at a really high level back into the drinking water if the salt level is not maintained. For adsorption media, all of the types, iron, titanium, iron-impregnated resin hybrids, they're all good for arsenic 5, but not so good for arsenic 3. Even though they may pass certification and they remove arsenic 3, the capacity may be low. And the medias for arsenic removal are very expensive, and you don't want to have to change them out too often. So some pictures. On the left, we have a reverse osmosis system, just 3 small cartridges, only effective for arsenic 5. You only get the 1 small tap. People will think, oh, it's an under-sink unit. My kitchen tap is going to produce arsenic-free water. No, you just have the RO water. Then the same thing, you can put arsenic adsorption cartridges in at point of use under the kitchen sink as well. And these go in Jersey between $400 and $800 installed. However, point of use is not the best. Whole house treatment is better. There's 2 studies, one in Maine and one that I did, that showed that when you do biomonitoring on people that have point of use versus people who have whole house, the people with whole house are getting less exposure than the people who are using point of use. Thanks. Okay, so what do these things look like? Here's anion exchange. If you're a water treatment person, please label the tanks. It looks just like a water softener. If there's no label, we don't know what it is. If you have any jurisdiction, if your health department, require them to label the tanks. So just remembering with anion exchange. It doesn't remove arsenic-3. It can dump the arsenic. What happens is it's pulling out other anions. So the arsenic is in parts per billion. The sulfate may be in parts per million. The resin is going to prefer sulfate over arsenate. And if there's no salt in the salt tank, and just let me say, in the homes I go into, 50% of the time, there's no salt in the salt tank, 50%. So we discourage everyone from using anion exchange except to use it to lower the pH. This is what we call our preferred technology, which is a whole house 2-tank system with arsenic adsorption media. This is a picture of what it looks like in real life. In Jersey, this system costs about $3,000 to install. Well, what about co-contaminants? So I already mentioned about sulfate being a problem for anion exchange. You can have the same problem with nitrate. Phosphate and silica are going to compete for adsorption sites. Iron bacteria, if the well has arsenic-3, it's probably going to come up with iron, and it has iron, and may have iron bacteria, and they'll slime the media. And then the arsenic can't adsorb into the media because the bacterial slime is in the way. So you need to pre-treat with oxidizers to kill the iron bacteria. And then I mentioned the radium before. If you're using manganese dioxide media, which is like green sand, Pyrolux, berm, stuff like that, they will absorb radium and not let it go. The radium is in there, and the tanks become radioactive waste, and I'll have a video of that in a bit. So that's it for arsenic. We have a really great arsenic awareness website with many frequently asked questions. Simple URL here, tinyurl.com/arsenic FAQs. I recommend you check that out if you have arsenic issues, and you can send homeowners to this website as well. Okay, into the radioactive elements. Red, here's testing again. There's a lot of areas where we don't have testing. You can see Jersey's bad for everything. Here's uranium. This is uranium in soil. The dark areas is where uranium's high in soil, so it's probably going to be high in groundwater, so you can see a large part of the country could be dealing with uranium. And then where you have uranium and radium, you're also going to have radon. So these are what are the radiation health hazards? They're all carcinogens. What are the radioactive emissions? So we got alpha particles, beta particles, and gamma rays. I have a couple of videos for people who are not familiar with the radiation to just get the basics here. We're going to see a video. This is a radioactive alpha source, and I don't know if the sound is going to work, but you'll see that the detector picks up the alpha particles, but the alpha particles don't go through paper. It may damage the paper, but they won't go through. So check this out. So that's alpha particles. Here's beta particles. Beta particles go through paper. But they don't go through the plexiglass. So if you have a treatment tank and it's got alpha and beta emitters, those alpha and beta particles are not going to come shooting out of the tank. They can't penetrate the tank. It's the gamma rays that are going to be shooting out of the tank. So here's a gamma source. It takes a 2-inch lead brick to stop the gamma rays. So we test for gross alpha. What does gross alpha mean? So it's, look over here, the down arrows are showing the isotopes that are alpha emitters, and up on the top left, we're starting with uranium-238, and each down arrow are isotopes in the decay series. They're going to emit alphas. So when they're analyzing the sample, they're counting all the alphas. It doesn't tell you which element it is. It's just going to tell you there's a lot of alpha sources. Radium's highlighted in yellow because it's a really bad one. It's going to absorb into your bones, and there's radon right after the radium. What are the standards? So they're all carcinogens, so the goal is 0. Gross alpha, the standard is 15. Just for comparison, what we have in Jersey, we have wells up to 2,000 picocuries per liter gross alpha. For radium, the standard is 5 picocuries per liter, and uranium is measured in micrograms per liter at 30. And you can see we have wells up to 1,200. There's no federal standard yet for radon in drinking water, but they've been talking about 300 to 4,000. In New Jersey, our Drinking Water Quality Institute, which recommends MCLs, recommended 800 picocuries per liter, but hasn't been set as an MCL yet. We have wells up to 200,000. It's sad to see everyone arguing about, oh, is it 300, 4,000, 5,000, 10,000 when people are out there with water at 100 or 200,000. So what works for the radioactive elements? Radium is very simple to remove with a water softener. It's a cation. It comes out with cation exchange. It can also be removed with reverse osmosis. Uranium is an anion, very simple to remove with anion exchange. You can see the cost. Both of these are under $2,000. The anion may lower the pH, and you may need a neutralizer afterwards. If you're starting with a pH of 7, it may knock it down to 5, and that's going to corrode the pipe, so you may need a neutralizer. And radon in water, if it's under 4,000 picocuries per liter, granular activated carbon works. If it's above 4,000, the carbon's going to become really radioactive and it'd be emitting gamma rays into the house. And so at those levels, you want to go with the aeration system above 4,000. So what does it look like? Here's a water softener. It removes radium. Why does it work? Because here's your periodic table. Softeners remove cations, calcium, magnesium, and all the elements in the column behave the same way. So there's radium at the bottom of the column, so it behaves just like calcium. That's why a softener works, and that's why it's absorbed into your bones just like calcium. Here's an anion exchange system. It looks just like a water softener, so please label it. Here's granular activated carbon for radon, and maybe more importantly, to see a bubbler. This is a water tank for aeration bubbling. What's good about these is the radon is basically bubbled out and blown out of the house. So there's no radioactive material left in the house, as when you have carbon. What's wrong with this picture? The tank on the left here is a granular activated carbon tank that's too close to the living area, so that you can see the finished basement. There's a big screen TV there, and when you sit on the couch, you're getting hit with gamma rays because it's too close. So we asked the homeowner, and I asked the treatment installer to move the tank to an outside wall. They moved it about 8 feet away, and then the level on the couch was fine. If you're going to deal with wells with water, radioactive wells and radioactive treatment systems, you should get one of these micro R meters to measure the radioactivity. If the level is above 50, you're really not supposed to transport this. If you try to take that over the George Washington Bridge, it's going to set off an alarm, and the SWAT team will be chasing you. If the level is over 2,000, first step back from the tank, and then call your Environmental Radiation Bureau to figure out what to do with it. So we'll see if this video will work. Okay, we're in Vernon, and we're at one of the most radioactive wells in the state. The water treatment system tanks have become radioactive, and hence we're getting some very high readings on the tank here. You can see it's reading about right there, about 90 microhour per hour. If we come back here, you can see the meter pegging on that scale. So move it up to the 500 scale, and about 320 microhour per hour. This unit here is the radon water aeration system. I'll turn off the sound. This is a water softener which removes radium. Got some levels in it. around 220. This tank here is an anion exchange resin. Removes the uranium and the arsenic, and it's reading around 150. This is a neutralizer because this anion exchange resin reduces the pH, brings the pH back up. And that one is not very radioactive at all. Any questions? All right, so you can see these things can get radioactive. Green sand, these manganese dioxide medias, this tank, the radium was, radium-226 was over 1,600 picocuries per gram in the tank. And if it's over 50, that's a problem in most cases. So I wish the manufacturers would put a label on these types of medias, do not use with water that contains radium. Because basically you're making what they call technologically enhanced radioactive, technologically enhanced, naturally occurring radioactive materials, which are a problem. You have to test the systems. We recommend people test once a year under stress conditions, which means run the water at normal use. And we have guidance out there. We have one for South Jersey where we're mostly radium, and one for North Jersey where we're mostly uranium. And that's basically it. I don't think I need to repeat my take-home messages. Any questions?
There are. All right, thank you. Yeah, there are a number of questions. The first one is, where does one get arsenic speciation cartridges?
On the slide, there is a name of the place where we get them from. I can't remember it off the top of my head. You could Google arsenic speciation cartridge. How about that?
That'll do it. Okay, so the next question, what kind of formation is arsenic found in? Geologic, I guess. I mean, which one?
So in South Jersey, we have a very low pH sand aquifer, and the sand grains have some manganese coatings on them. Radium loves manganese. So the pH is low, it's like pH 4.5. The manganese dissolves, the radium goes right into the water.
This is about arsenic?
Oh, that was arsenic.
Yeah.
Okay.
Like we have arsenopyrite in our sand and gravel in Illinois. That's where most of it comes from.
Yeah, we have arsenopyrite in the bedrock, and it weathers and releases. You know, the levels of arsenic are super high in the pyrite crystals. That's our main source.
So I've read that there's a chance that arsenic from well water might aerosolize in the shower, adding inhalation to the household exposure. What's your take on this?
The arsenic does not volatilize, so you're not really going to inhale it. I mean, if you're inhaling water vapor, you can get, but that's a small amount. So I don't see that as a problem.
So will aeration prior to RO remove arsenic-3?
The aeration should convert the 3 to 5, and then the RO will take the 5 out.
Yep. Should you have had a hazmat suit on in that basement?
Yeah, no. Below 2,000 is, like 2,000 is like the occupational health hazard level.
Oh my. So this is a question from a lab. If they do arsenic speciation, would they want to separate the sample themselves and analyze 2 samples? And is there a cost-price difference?
So there is a way, like the USGS lab, you can put a preservative in the sample. They use an amber bottle, so that because sunlight and UV could convert it from 3 to 5. So the commercial lab will give you their method.
All right, we are out of time, so we'll get the rest of these to everyone later. Thanks again, Steve.